Okay, so today, for the last day of the week, I am going to go over the examples for lesson 3, and we're going to finish off the area portion. So I introduced the concept of area yesterday, or 2 days ago when we did the assignment yesterday. Area, again, is two-dimensional, and thus far what we talked about the area of regular shapes, kind of those traditional shapes. So if I just flip back for a sec, yesterday's assignment, we did the area or the perimeter of these two shapes. We did the area just of the regular, either the circles, triangles, or rectangles and squares. So they were very easy to deal with. We just referred to our formula and used it accordingly. Now what we're doing is we're doing areas of irregular shapes. So you can see our first example. This is not just a rectangle or a square, right? Now, this looks like the floor plan of a living room or a house. What it does look like to me, and hopefully you can see it, it's like two rectangles pushed together, right? Or one large rectangle with a chunk taken out of it. So when we have a composite shape, it's made up of, the word composite means it's just been made up of two other shapes. So what we can do in that case is there's a couple of ways we can do this. We can divide the shape up into two separate shapes, right? The other way I could do it is find the area of a whole rectangle, pretend a whole rectangle was there, and subtract out the missing part. But I think I'm going to do it this way. I am going to, this is sort of a more traditional approach. I'm going to draw an imaginary line down here. And I'm going to call this area number 1 and area number 2. So if I take the shape and I divide it into two separate shapes, you can see that I've created two rectangles. Okay, I've got two rectangles, kind of long, skinny one lying flat on its side and one more vertical one. I can easily find the area of this rectangle, then the area of this rectangle. If I add them together, I have the area of the whole shape. So that's one way to approach it. Now, I also, just so you know, I could have carved up instead of drawing my dotted line here, I could have drawn a dotted line here, and I would have had the area of a longer rectangle and then a small one on top. That's also a method, however your eyes see it, right? But you'll end up with the same answer. Okay, area number 1. This is 15. Now, if because I have a notch here and a notch here, it means these two are equal in length. And if this whole side is 10 centimeters, then that tells me that this has to be 5 centimeters and this has to be 5 centimeters. Therefore, I have the two dimensions of my first rectangle, 5 times 15, which is going to give me 75 centimeters squared, right? I have to use the 2 because I have two numbers I'm multiplying. Area number 2, let's see what area number 2 will be. 10 by 8. Okay, so the total area of this composite shape equals 75 plus 80, 155 centimeters squared. Okay, and that's it. So there's all kinds of composite shapes, right? It might not be two rectangles pushed together. It might be a rectangle and a triangle, or a rectangle and a circle, or a circle and a square, but that's how we handle composite shapes. We'll go on to another. So this is composite or irregular shapes, right? Now we're going to go on to another type of question that you see commonly in this part, in this section of the unit. It's called shaded area. So what does that mean? Find the shaded area of the following figure. So basically, they want me to find the area of this piece and this piece and this piece and this and this and this, which are weird, right? If you look at any one of these individual shapes, it's this weird, it almost looks like a triangle, but it has a curved side. And even if it were a triangle, it would be very difficult to figure out all the measurements of these little individual triangles. And it's not a triangle, it's actually it's like the tip of an arrow, right? We don't have an area formula for that particular shape or for this weird shape, right? If you just look at the shaded part. But if I kind of step back from this picture and look at it a little more closely, I can see I have a rectangle and two circles. So I do know how to find the area of a rectangle, and I know how to find the area of a circle. So therefore, if I found the area of this whole rectangle and I subtracted out the areas of the two circles, that would leave me with the shaded part. So that's basically what we're going to do with shaded areas. I'm going to find the area of the rectangle. And I'm going to subtract the white parts out, right? The areas of two circles. And if I do that, that leaves me with just the shaded part. All right, what's the area of the rectangle? Well, this is this is really testing your knowledge of shapes. All the way across is 20. Now there's a big assumption here. We're assuming that the circle equals this circle. So we have to assume that. Maybe that's a big assumption, but that's what we're assuming here. So something interesting, if the area of this, if the length of this whole side of the rectangle is 20, that means the distance across one circle would be, the diameter would be 10 meters, agreed? And the diameter of this one would be 10 meters as well. So that also tells me the diameter of a circle, it doesn't matter how I take the diameter this way has to also equal 10, right? If this distance is 10, then this distance has to be 10. So that tells me that the width of this rectangle is 10 centimeters. All right, so the area of the rectangle will be 20 times 10, which will be 200 meters squared. Okay, so there's my rectangle. Now let's find the area of the circle. Remember, area of the circle will be pi times r squared. Well, if this is the diameter, the radius will be 5. Okay, so pi times 5 squared. And there's 2 of them, right? This is for 2 circles. This is the area of one circle. And, whoops, erase that. So the area of one circle, and this is the area of 2 circles, right? Now I'm probably going to have to do some rounding. I need my calculator for this one because of that pi symbol. So 2 pi times 5 squared, and I get 157.08 meters squared. So I have to subtract, right? I'm doing a subtract. So 200 subtract, and I get 42.92 meters squared. So I'm just going to record that below here as well. The area of the shaded part is 42.92 meters squared. So that's how we handle a shaded area part. Kind of nifty. So let's go on to the next example. Example 3, fraction of a shape. Find the area of the following figure. Okay, so I have a circle and I've got a wedge coming out of it, right? So the area of the following figure. So I think this is I think they're asking me to find 3/4 of the area of the circle. Again, there's a couple of ways I could do it. I could find the area of the whole circle and then find a quarter and subtract the quarter. Or I kind of see it's 3/4 of the area of a circle. I know how to find 3/4 of something. This is the radius. The radius is 5 inches. So I want to find 3/4 of pi times 5 squared. So 3/4, that's easy enough, right? It's just 3 divided by 4. Of means multiply. So 3/4, or you could think of 3/4 as 0.75, right? If you recognize that 3/4 is decimal 75. So 3 divide 4 times pi times 5 squared equals 58.90 inches squared. Notice I'm not going to use the symbol for inches, the two little notches, because if I use the two notches and a 2, it just looks like exponent 112. So I'm actually going to use the word inches, IN. Let's look at the next example now. Putting it all together. Find the area, shaded area of the following figure. Okay, this is a very strange. So I need to find the area of all the shaded pieces. Well, this, they're asking me to find the area of half a circle. Okay, I can do that. I can do that the same way I did the previous example. Now this strange shape, I don't have a formula for this strange shape, but I'm going to find the area of the rectangle. So I see the area of this rectangle, and I see the white part is a triangle, and therefore I'm going to subtract the area of the triangle. So there's just a lot going on in this question, right? So let's find the area of the circle first. So, and then I'm just going to divide it by 2 or 1 divided by 2 times the area. So what do I have here? All the way across is 4 miles. So the radius equals 2 miles. I don't know if that shows up. So I'm going to just do it in black. Radius equals 2 miles. So I'm going to, let's do this, half of pi times 2 squared equals 1/2 times pi times 2 squared equals 6.28 miles squared. All right. Now let's work on this part. So the area of the rectangle is 7 by 4. So I have 7 by 4 equals 28 meters squared. I'm just going to box this off for a sec so I don't forget about it. Subtract. Now, area of a triangle. What's the area of this triangle? It's 7. Okay, they're saying I've got a notch and a notch here. So that means this is 2 miles and this is 2 miles. Okay, so that's my base. My height is 7. So area of the triangle is 7 times 2 divided by 2. That's just going to give me 7. Okay, so minus, I'm just going to move the 7 over so I don't have to rewrite it. Okay, 7 miles squared. 28 minus 7 is 21 miles squared. So they want the total shaded. So now I've got my weird shape and my half circle shape. So total area of shaded part is 6.28 plus 21, 27.28 meters squared. Okay, and I think that's it for examples. So now you've got a nice assignment to work on, and it might be challenging. You've got these three are just composite shapes, so no shading. So just use your imagination, try and see other shapes, all the shapes you can in here, separate them out into their individual shapes and add them up, add the areas, individual areas up. And then here, this involves shading. So use our concepts of shaded areas. Basically, find the area of the larger shape and subtract out the smaller shape or shapes. So I'll leave you with that to work on for the weekend or the rest of today. And we'll reconvene on Monday.